Hi everyone, this is the introduction to the blockchain. So this is the first page. Let's go to the next page. So here I wanna introduce a bit myself. My name is Ademi, and today I'm here to present 3 subjects in a blockchain. If you wanna contact me, you can find me via email. So let's go to the first part. How the blockchain works. So if you move to the next part, we can see the code. So blockchain technology could change our world more than people imagine. Bitcoin, however, could be a bubble. So let's go to the blockchain. What is the blockchain like in general? A blockchain is a distributed database that is shared among the nodes of a computer network, and it's a database. A blockchain stores information electronically in digital format. So there are some characteristics of a blockchain. First one is digital ledger. What does it mean? It means that a blockchain is a digital ledger which keeps records of all transactions taking place on a peer-to-peer network. Second one is encrypted information. Encrypted information is all information that is transferred via blockchain that is encrypted, and every occurrence recorded, meaning once the block is created and added to the chain, it cannot be altered. Next one is peer-to-peer. Basically, it means that if you have to interact or send the transaction with a peer without an intermediary, so removes the middleman. And fourth one is data sharing. Data sharing is so the blockchain can be used for more than the transfer of currency. It can also be used to share contracts and records and any other type of data. And the last one is the centralization. So it means that the blockchain is decentralized, so there is a need for central certifying authority. Let's move to the next part. So next part is a blockchain demo. In this part, it will be explained how blockchain works, and this is how the demo version looks like. So here, as you see, there will be hash, and in this hash, so it basically like demonstrated. So there's like blockchain demo. It includes like hash, block, blockchain, distributed blockchain, transaction tokens, and Coinbase. Hash is mostly like unique part. For example, if you enter the data, there will be like unique hash. This is like shortly about blockchain demo. I will add the additional video and will show how the blockchain demo works. This part, I'm gonna explain how blockchain works on a blockchain demo. At first, I want you to look at the screen. So here we see like the hash block. And here you see the demo version of hash, but before I will start, I want you to pay more attention onto that part. It calls SHA-256 hash, and this hash is shown below and looks like a bunch of numbers. Basically, it's a fingerprint of physical data. So for example, if I type my name here, the hash will be changed and it will be unique only to the data I write. And the rule is that the same data will give the same hash. To extend the idea of hash, I will go to the blocks. It's here. And so this is how it looks like. It is exactly the same thing, but there are more sections and a special box with the data to put in. So what will happen if I type something here? Like let's type hello. So we see that background is changed. It's showing red. It means like the information or the data is not valid or not signed with the hash. So it is not signed with the hash, and it will not automatically like changed. What we can do to match it, we have to find a data with the same hash. So we see numbers here, we can type 1 and check it, but it's not working. The thing is like if I just press the remind it's changed automatically, and it's showing me that the hash was like I will start with the 4 zeros. So now it's like valid and matched with the data. So this is how blockchains works, but we can search it forever, and there will be like a lot of blocks. So to understand in that way, I will go to blockchain. So what is the blockchain? How we put all things together? There are 5 blocks in it, as you can see. And the thing is, like, if you see, here's the hash, and the next block will have the same hash here, which is like the previous one. As we can check it here. So here's the hash, it starts with 4012, and here's the previous is the same, and here's the same. They're using the previous hash from the previous block. But what happens if I change the data? If I change the data, it's showing me like the background is changed again, so the information is not valid. If I change the data here, it's showing me that this block and the next block are also not valid. If I change the first block, it's showing me that all the blocks after the first block are also not valid. So what I can do, for example, let's type hello again and remind it again. It's showing, it will take a little bit time, and it's showing that it's matched again. But what if I change the data here and remind it also? So it's showing me that the next part not changed. I have to remind them also, and only after that they're gonna work and will be valid. This is the how distributed. This is the how blockchain works with the 5 blocks. If I'm changing the last block, I have to change only that one. From this example, yeah, this can be like considered. If I change the last block, I have to change only, like, remind it only the last one. But if I change the first one, I have to remind everything. Now let's go to the distributed blockchain. It shows that we can see peer A, peer B, peer C. So all the blockchains, they are copied to each other because they have the same hash. As you can see, they are just copied. And but how do I know that if I made the change in one peer, it will be mine in other peers too? If I change in block 5, for example, in a peer B, let's say hello, and remind it, it will take a little bit of time. Yeah, it's changed. Now we have to check how it showed like on other peers. For example, we see like in peer A, the hash is starting with 40. We saw 40E4, and here's in peer C is also 40E4B, the same as the peer A, but the peer B is different, so we have to remind all of them. Then it will be changed. It will be changed. The hashes in A and C is similar, but B is different. So this is how distributed blockchain works, and tokens will be explained in the future. Thank you for your attention. This is the end. And next one is example of how Bitcoin transaction works. So at first, let's start what is the Bitcoin itself. So Bitcoin itself, it means like, so this is like the first part of the like cryptocurrency and all the like blockchain. And so Bitcoin is a decentralized network of the digital currency. Transactions are made to and from 16 characters encrypted addresses. These addresses are mathematically secure to that nobody but the owner of the addresses can transfer the funds that belonging to it. So to put it simply, Bitcoin is a network of independent computers that generates, propagate, and verify monetary transaction. So, and I want to explain like how Bitcoin transaction usually made. So basically, at first, for example, let's say like in the pictures, you can see there is the example of Alice. Alice wants to send Bob 2 Bitcoins. At first, you need to like to make the transaction request to the blockchain itself, and then it will be distributed in the database and round between like thousands of computers globally. Second part, computer knows that as a miner, it should be verified that transaction is made, and check Alice balance and compete the place it into a block with the other transactions. Third part is to append a block to the chain and prior blocks. Fourth part, others in the network check in the miner's work. Fifth is Alice transaction gets to add it to the blockchain along with the others. And the last part, Bob will receive the 2 Bitcoins. So this is basically how the Bitcoin transaction is made. So let's move to the next part, And next part is second section. Second section is about smart contracts. So basically you can ask the question like, what are the smart contracts, what the use cases of smart contracts, what is the benefits, why we should use that. So in the next slides I'm going to explain that. So let's move. Smart contracts. Basically, as it said here, a smart contract is a computerized transaction protocol. But if we go more deeply, smart contracts are simply programs that stored on a blockchain and that runs when predetermined conditions are met. So typically, it is used to automate the execution of an agreement so that all participants can be immediately certain of the outcome without any intermediaries involvement or time loss. Here you can see like a basic characteristic of a smart contracts. So first one is agreement, then is protocol, it is decentralized, there should be a code, it's automized totally, and it's a part of a blockchain, and it means like it's secure. So let's move to the next part. I'm going to explain how smart contracts like simply works on a soccer example. So in other words, so if we say that a smart contract executes in a specified path dependent on the variables. Consider a soccer match in which party A, as you can see, is like pink circle, is playing against party B, is like blue circle. So, and they want to like to find the outcome. So today's Web2 environment, you will need to go to be trusted third parties such as Unibet, as you can see here in the middle. And it gives you monies like monies to Unibet, where this TTP will look for a peer that bids against your wager. However, Unibet is still in the center as a centralized trusted third party. Unibet is consequently subject to the three major risk categories. They can falsify or exclude your money and everything you just give them, or run away with your money, charge a fee, it will take a time, and other like so many like issues can be. And so instead of the including Unibet in this equation, why don't we use a smart contract between these two parties, between party A and party B? So party A and party B both deposit funds into the smart contract instead of the Unibet, and the soccer game is about to begin. So let's imagine that depending on the success of the game, the ultimate score of the game, which is a variable input for the smart contract, is the same as pressing the T button on the screen. Things will begin to happen as a result of the pact determining the road to be walked. So the outcome of the soccer match, like how they can randomly choose input for the coffee machine, also provides random input, but in a different way. Assume that party A bets on Real Madrid to win, and party B bets on the Barcelona, like La Liga. So to win. So Barcelona wins in the end. For example, we put that input is contract, which equal to result match. As a result, the smart contract received the input. This time Barcelona wins instead of the cup of tea, and the information is received at the conclusion of the game and is registered on the official site of the Barcelona or like UEFA. And the contract examined. So there will be like some steps. The first step will be the question: did the party receive the entire amount of the money if they win? And also like in the back way. And step two, if Barcelona wins, the party B should transfer money to party A automatically. So step two, if Real Madrid wins, it will be transferred money to party B automatically. And another step is that if it's like a tie, the smart contract will just return the funds. Because this contract is completely open and transparent, everyone will be able to observe what it will accomplish in advance. You can check the possible roads ahead of the time, so you know that ahead of the time that the party B refuses to pay, party B money is already locked in the contract, so they cannot cancel it, which depending on the conclusion of the match will be automatically delivered to a specified direction. If you have a friend who bets but never pays, create a smart contract so they can be your friend and can't back out. In this situation, party A is pleased since Barcelona wins and they does not decentralize ledger, which ensures the security of your data. You can see where it's hidden with the lower TX expenses benefit decentralized. As a result, we're expanding of this decentralized infrastructure with the new technologies that operate autonomously without the participation of a person. We can wager on a sports game without human interference. Just as I produced already, they're like the basic example with the cup of tea. You can find it like in the internet or like everywhere. So it means like without the human intervention, like in a physical world, a digital world, it doesn't matter. As a result, it will be taking the software industry to the next level of automation. The following stage of a smart contracting is the formation and organization of society, such as decentralized autonomous organizations that operate in automated manner on a public blockchain. It may be viewed as a decentralized application. So in the next page, you will see you can see important notes about the smart contracts. First note is about important limitation. As you can see, once launched on the blockchain, you cannot alter a smart contract, which is basically means that this imposes searching contracts and smart contracts. One of the most important characteristics of smart contracts is that once the contract is established, it is in a sense in stone. So ever better stone registered on the unchangeable blockchain. You can't change the data until you change the hash. Smart contracts are also hashed, just like the public keys. So you have to go over the further depths later in level 2. And second one is unstoppable application, which is means like a smart contract on a public blockchain is an unstoppable decentralized application. This is because, for example, when you combine this decision tree, if that routes, so you put the rule, if you combine these smart contracts multiple in a row all into one colossal decision tree, you can eventually create your application connect decision tree. And because it runs on a decentralized environment, an open public blockchain, you have a decentralized application. So let's move to the next slide. So here we're going to discuss benefits of the smart contracts. There are like 4 benefits of the smart contracts, as you can see. And first one is speed and efficiency and accuracy. It means like when there is a condition is satisfied, the contract was instantly executed. Because smart contracts are digital and automated, there will be like no paperwork, so there's like no handling of like and no wasting time correcting errors that frequently occur when filming out of forms manually. And second one is trust and transparency. I think it is understandable. There will be no waste of money, no like frauds, no lies, no how can I say that, no seeking your money. So there will be like all the trust and transparency, like all the parties can see what is going on between their contract. And third one is security. Blockchain transaction records are encrypted, making them extremely difficult to hack. In addition, because each record on the distributed ledger is linked to the preceding and subsequent entries, hackers will have like to modify the entire chain to change the single record. So which means like basically it is not possible to hack it. And first one is savings. Smart contracts remove the need for intermediaries to handle transactions, and by extension they associated times delays and fees. Okay, there are like an example use of smart contracts and all the categories. So as you can see, there are like automotive or like charity, storage, credit history, education, energy forecasting, I don't know, medicine, insurance, and everything. So smart contracts can be used in every category in our life. It only like matters when all the categories will be like online and decentralized. So let's move to the final part of our presentation, is different types of players. And different type of players, they're like users, miners, minters, nodes, and validators. I'm gonna go and explain like only part of them and shortly because we're running out of time. And so let's move to the next slide. It means there are like different types of players. As you can see, first one is users, miners, and minters. Third one is nodes and validators, developers, other ecosystems, entities, and I will move a bit, and open source ecosystem. So this is actually interesting. First one is users. A blockchain usually doesn't care, like it is open and usable for everyone, so it doesn't care who owns the private key or public addresses, which means like it's safety and secure. And second one, the Web3 technologies can not only remove the Uber, for example, as the intermediary, but even the car driver. So the future like will be without like any third parties. And for example, let's talk about more users. Machines and other autonomous like entities can now own their own private keys for the first time in human history, because Valo is entirely digitalized. Bits and bytes may directly send and receive other bits and bytes data because of the public-private key pair reflecting a digital identity in conjunction with the automated smart contracting mechanism. There is no need for human intervention. So you can hold your private key whether you are a machine or a person. As you're now aware, this is simply a large number that has been mixed using the ECT as hashed and provided to the outside world of the public key. As a result, blockchain technology allows and supports future technologies such as the Internet of Things for more effectively than centralized systems like in real life, which means like due to the reduced transaction cost, which is equal to more efficiency, which can be like a good advantage. And combine this with the reality that machinery, automobiles, and several other types of hardware exist. Lantern, post, and washing machine may now become self-sufficient and self-sustaining, take care of themselves. You may have a self-driving automobile that only drives when it's given money and instructions. It will recognize when it's needed repair, when to pay the garage, and when to make more than its cost. It may even be able to purchase a second self-driving automobile. So, for example, in my experience, I live in the student hotel, and there are also like some washing machines. There is no third party you have to like discuss or like pay. You only pay and like make a smart and fast contract between the like washing machine. You just pay, and after it's gonna automatically work. And next slide is about miners. So miners are minters and record a validate transaction and offer the ledger security. They replace the role of the TTP. A mining service is frequently nothing more than as an intermediary that enables mining participation. Do not forget and do not make mistake it with mining pools, because where you must often set up and enlist yourself unless you do it via mining service who does it for you. A mining pool should be not be confused with the mempool. Mempool is where transaction between users and held before being gathered by miners in a block. A mining pool is nothing more than a group of individual miners pooling their hash power to maximize their choices to obtaining the bitcoins. And next page, mostly like in the last one, nodes and validators. Validators are nodes which operates and each store and a copy of the blockchain and must perform certain functions to keep the systems secure. And if we talk about the nodes, all nodes on a blockchain are connected to each other and they constantly exchange the latest blockchain data and information between each other, which helps to nodes to stay updated. Yeah, and also like this blockchain is decentralized. Once like the nodes were updated, it will be updated automatically to all the like users. They also, in addition, they store, spread, and preserve the blockchain data. So theoretically, a blockchain exists on the nodes. This is the end of my presentation, and I want to say thank you. If you have any question, you can contact me via email, as you can see here. And thank you very much. Goodbye.